it tells me that this is the Green's theorems with holes. What do I do? And I told you the breakdancing, so I'm gonna go, oh, I messed up. Why did it not, I don't know. This is C1, this is C2, this is C3, C4. My fault for not preparing this ahead of time. So when I'm computing this, again, the story of breakdancing. What is the story of breakdancing? Palm of my hand right here. If I'm going there in any of the boundary, the palm of my, in the direction of the boundary, palm of my hand should be facing the shaded area. So for that one, for C2, see how if I'm going to go like that, palm of my hand is going to be toward the shaded area. But for C3, if I'm going like this, because I'm going to face, my palm of my hand is going to face the hole. And for C4 also. So as long as palm of your hand is facing the area, you get positive. So basically, if I want to use, if you want to use Green's theorem, you can have a C with piecewise that is consistent of C1 with a positive plus C2 positive minus C3 minus C4. So that's the Green's theorem connotation. Yeah, I always worry that I put these things wrong. Okay, there we go. And so that's the Green's theorem thing to do. And some people kind of say that it's like the outside one should be counterclockwise, then inside one should be clockwise to be positive, and the other way around is going to be negative. Outside counterclockwise is positive, inside clockwise is positive, the other way is negative. That's how people deal with these things. And so basically use that. And so with that C, you will have this equal to the area of you're equal to the curl of F in Z direction, dA. But curl of F is just a constant, 6. Right? So basically, the right-hand side of this story is just going to be, it's going to be 6 times the area of D. Because the integrand is 6. And so the area of D, let's compute the area of D, 6 times pi times 5 to power 2 is the area of this big circle, minus area of the 2 small circles, 2 times radius is 1, so 2 times pi. Then I have the area of the square, which is 4, right? 4, and the entire thing gives me, oh my goodness. I'm gonna 25 pi minus 2 pi, 23 pi, 6 times 23 pi minus 4. Am I right? Yes. I messed that one up. So I found the right-hand side of this. So why am I doing this? Because it's discussion. Again, this time, the left-hand side is unknown to me, or a piece of the left-hand side is unknown to me. Piece of the vector line integral is unknown to me. And so I want to find that piece. And so how do I do that? Here I say, this is basically equal to the integral f dot dr plus C2 f dot dr minus C3 f dot dr minus C4 f dot dr. And some of these things are given to me. That one is given is 3. That one is 7. That one is pi. So basically, the left-hand side is just this minus 4 plus pi. And the right-hand side is just that. And so that allows me to compute this is okay. It allows me to compute f dot dr, which is going to be that. Over C1. Okay. Are you guys still with me? You're okay? Was this okay? So that's the story. It just basically with problems like this, we're expecting you to figure out this. This is for you guys to remember when region has holes, you still have a way to do this. It comes in handy in some areas, basically. In solving equations, it comes in handy, basically. Different area of the science required in different ways, basically. So that's the story. Now we're at the point of the flux. Are you guys still there? What?